So here is our scenario. All right, we're going to say that Paul is a 65% free throw shooter. Probably giving him a few extra percentages there. Okay.
Like
all right.
20.
Okay, maybe. But anyway, 65% maybe cookies. All right, cookies 65% shooter. All right. Anyway, so let's say we're going to go down to the gym. We're going to shoot. He's just going to shoot 3 free throws. Okay. What is the probability that he makes all 3? What is the probability he makes 2 of the 3? What is the probability he makes 1 of the 3? What is the probability he makes none? Okay? All of those are possible outcomes when you shoot 3 free throws, right?
Yeah.
You could make them all, you could make 2, you could make 1, you could make 0. They're all possible, okay? We're going to figure out how possible each one of those outcomes would be, okay? Now, you probably have a pretty good guess which one's most likely to happen.
2 or 3.
Hitting 2 out of 3, right? Because 2 out of 3 is 66 2/3%, pretty close to 65%. So more likely, the best possibility would be him making 2 of the 3. But again, I want to see how likely those other outcomes are. Okay. So with that, all right, let's do a couple of the easy ones. All right. What is the probability that he makes 3 of them? What would you do to figure out the probability of him making and then making and then making? Try to give you a little hint there. 65% times 65% times 65%. Because what's the probability he makes the first free throw? 65%. Then what's the probability he makes the next one? 65%. And what do you do when you have multiple events like that? You multiply the probabilities together. So you would take 0.65 times 0.65 times 0.65, or really you take 0.65 and raise it to the 3rd power and you get your answer, right? Okay. Those of you with calculators, just a little bit of help here.
0.27%.
0.27. All right, we can go to the nearest percent. Yeah, I suppose. Let's go. So 0.27, or about 27%, right?
Pretty good.
Okay. Did it round to 27, or would it be 28?
Round to 27.
Okay, all right, just double checking for round to 27. All right, so probability makes 3, 27%. The other really easy one to do would be the probability that he makes 0. How would you calculate the probability of him missing all 3 of them? 0.35 times 0.35 times 0.35, because if the probability of him making a free throw is 65%, the probability of him missing the free throw must be 100 minus that, or 35%, right? So the probability that he makes 0, you do 0.35 times 0.35 times 0.35, or in other words, 0.35 raised to the 3rd power, and what would that be, roughly? 0.04, okay? So only about a 4% shot that he misses all of them. Still possible, all right? 4% chance of making 0. All right. So how about the probability that he makes 2? How do you think you'll figure that out?
0.65 squared times 0.35.
So 0.65 times 0.65 times 0.35, you're saying? Like that?
Yeah.
Okay.
0.15.
0.15. Well, that doesn't seem to make any sense. Shouldn't this be the most likely one to happen? We're missing something. When you take 0.65 times 0.65 times 0.35, what are you finding the probability of?
Making the first 2 and missing the last one.
And what's the problem with that?
It's not, it's in order.
That's in order.
Yeah.
Aren't there other ways he could make
Yeah, you can
2 of the 3? Times it by 3. Because there's 3 different ways it could happen. You could go make, miss. Make, miss, make. Miss, make, right? There's 3 different ways that could happen. And even if you couldn't figure out how many different ways that could happen, you could do 3 NCR2. Because you're choosing some group of 2 out of the 3 shots. how many ways could you make 2 out of the 3 shots? 3 NCR2. You're choosing which 2 shots to make, and the order really doesn't matter. So, but like you said, there's 3 different ways. So after you get this answer, you take it times 3. Or in other words, you have 3 times 0.65 to the second times 0.35 to the first. I like the way that Burke put that when he said 0.65 squared and 0.35 to the first. But there's 3 different ways that could happen. It could happen in this order. It could happen in the 0.65, 0.35, 0.65, or 0.35, 0.65, 0.65. You get the same number, obviously, because you're multiplying the same numbers together, and then you'd have to add them all up. Or in other words, take it times 3, and what do you get there?
0.44.
So about 44%. Now that seems a little more likely because we knew this one should be the highest amount, right? That should be the most likely thing that happens is he makes 2 out of the 3. So that should be the highest, okay? Now, we'll do the math for the probability of him making 1, but also if you think about it, if you figured out the probability of him making 3, 2, and 0, you could figure out the probability of him making 1 because you know all the probabilities need to add up to how much? 100% or 1, right? Okay, so you probably could figure it that way. But I still want to show it to you the other way. So the probability of him making 1 would be like 0.65 times 0.35 times 0.35, but that could also happen 3 different ways, right? So you have 3 times 0.65 to the first times 0.35 to the second, and what is that? 0.2.
0.24. But if you add them all, it's because it's rounded.
It's because we're rounding. We're out. What does this math actually round to?
0.24.
0.24? Okay. Yeah, the reason they're not quite adding up to 1 is because we have been rounding all of these. So that's why I would try to avoid that. Okay? Unless you know. Now, if I would have written out about 5 or 6 decimal places on each one of these, you would have found you can be much more accurate on that last one. But because you're rounding each time, you could find the possibility of being off slightly. Okay? So here are all the different probabilities. Probability of him making all 3, making 2, making 1, making 0. All right. The probability he makes 3 is just a little bit higher than the probability of him making 1. But obviously the probability that he makes 2 is the most likely outcome. But again, all 4 of them could happen. Okay. Now, you're going to have to do a problem like this, but I'm going to have you shooting like 7 or 8 free throws. Okay. And now you're a little bit thinking, well, geez, that was a lot of work just for 3. To make this 7 or 8, it becomes a heck of a lot more. But if you look closely at this, okay, the probability that he makes 3, we did something raised to the 3rd power. And the probability he makes 2, and this is important here, we did 3 times something to the 2nd times something to the 1st. And you kind of should be looking over top of my left shoulder basically right now, or I might have gotten it in the way here. The next one we do 3 times something to the 1st times something to the 2nd. And then the last one something to the 3rd. Okay? So really, what you have going on here, you really have this x plus y to the 3rd where you did 1x cubed plus 3x squared y plus 3xy squared plus 1y cubed. But x, we could say, represents the probability of him making a free throw. Y could represent the probability of him missing the free throw. And then we're shooting 3 free throws. So to get each answer, making 3. Get this answer, and that's the probability of him making 3. Get this answer, and that's the probability that he makes 2 and misses 1. Get this answer, and this is the probability of him making 1, and then missing 3, and then missing all 3. So in a sense, you're really just expanding a binomial, but instead of having variables in it, you're having the percentage of it happening and then the percentage of it not happening. Okay? And what should all of these probabilities add up to? 100% or 1, right? that should make sense because what's 0.65 plus 0.35? 1. Raised to the third power? 1. Okay. Alright. 1 times 1 times 1? 1. Alright. So that mathematically should make sense. Okay? Now somebody, well, what if he shoots 10? What if he shoots 20? What if he shoots 30? And so on. Okay? Well, this 1, 3, 3, 1 we know came from the third row in Pascal's triangle. Right? You're not going to want to write 20 rows of Pascal's triangle or 30 rows of Pascal's triangle. But remember, each one of these values is really an NCR. Right? Okay? So really this 1 here is like saying 3C0 times 0.65 to the third plus 3C1 times 0.65 squared times 0.35 to the first plus 3C2 times 0.65 to the first, 0.35 to the second plus 3C3 times 0.35 to the third. So as you start to get into larger and larger and larger numbers, you won't have to, per se, write them all out. You'll know which one to use, in a sense, based on the pattern. Okay? Everybody had those written down, I hope. If not, watch the video again.
You got 20 minutes, Jack.
That's fine.
JK, you're not. It's like 11, I think.
11.
Doesn't matter. I've been loading them as a full video now, so that way you don't have to.
You learned how to do that finally?
Finally, yeah.
Who helped you?
Brady Edwards. Believe it or not.
Be rad.
All right. Another thing you'll be asked to do then is to create a probability distribution. And really it's just kind of like a histogram or a bar graph, if you will. Okay? But here's an example of a probability distribution. I colored in the first one and I just didn't keep coloring. You don't have to color them in, I don't care. But what we did here was we graphed, we made a visual aid here, of each one of those probabilities. Okay? And when you make your probability distribution, your probability goes up and down. Okay? Your probability goes up and down, and then the different outcomes go here along the bottom. Alright? So probability that he made 0 free throws, that was about 0.04, right? The probability he made 0 was about 0.04, so I tried to go up to about 0.04 and make my bar graph there. Probability he made 1 was about 24, I think you guys said, or something like that. Probability he made 2 was about 44. Probability he made 3 was about 27. So this is an example of a probability distribution, and this you will be asked to make a probability distribution for a problem. It is a free throw problem on the test, I'll go ahead and tell you. All right. You'll be asked to make a probability distribution after you calculate all those answers like we did on the previous page. Okay. What questions are you having so far? Anything coming to mind? Yeah.
You know how like when we rounded it, it didn't add up to 100%? Will we have to write out like 5 decimal places or something like that?
I think I asked you to go to like 3 decimal places on all of them, and what I would do, I still would probably do the math to get your answer on all of them, do the, raise everything to the power and do all the math, and then maybe at the end when you add all of your answers together, as long as they're really close to 1, you know you did it right. I mean, if you get like 100.1%, you know you did it right. Or if you get 99.9%, you know you did it right. Now, if it adds up to like 89%, I'm betting you have an error somewhere. Okay, so I think I asked you to round to 2 or 3 or 4 decimal places, but definitely to avoid making a small mistake, Drew, I would never find all of them but 1 and then subtract those rounded answers from 100% to get the last one. I just keep doing the math to get the last one. Okay. Because you don't want to use a rounded answer to get another answer that you're going to round.
Yeah.
Okay. So we want to try and use as accurate answers as possible. So probability distribution or questions in general like that. Anybody on this? So to get you kind of in the habit here, all right, let's say I increased it to 6 shots. Okay, he's going to shoot 6 free throws. What's the probability that he makes all 6 of them? All right, well, we can go down to the 6th row, all right, but let's say I didn't have Pascal's triangle handy.
Well, then I'll write it down.
Okay, you can write it out to the 6th row. Me personally, I'm just going to write this. Okay, because I know that the very first number in the 6th row is 6C0, which, yeah, I know it's 1, okay. But I want to show you 6C0, and then the probability of him making a shot is 0.65. How many shots are we making? 6. So I take 0.65 and I raise it to the 6th power. So I do this to get my answer for the probability of him making 6. Probability of him making 5, I do this right here. Because I know the next number in Pascal's triangle would be whatever 6 NCR1 is, which, yes, it's 6. Okay, we can see that over there in Pascal's triangle. But when I start making this 20 shots or 30 shots, you're not going to know each one of the numbers in that row of Pascal's triangle. Okay, so that's where you use NCR. Probability of him making 5 shots would be 6 NCR1 and then 0.65 to the 5th. Why do I take 0.65 to the 5th power? Because he's making what? 5 shots. Why do I take 0.35 to the 1st power? He's missing 1 shot. Okay? And then probability of him making 4, we do 6 NCR2, and then 0.65 to the 4th, 0.35 to the 2nd. We did that one together in the other class. There's about a 33% shot of him making 4 out of the 6. Okay? And we stopped at 3 because we had the hang of it. Alright, we could keep going with it. Alright. Let me point out a couple things here. And watch just a second. Stop. Those of you that are writing some of this down, just watch just a second. Okay. 6 NCR2. 6 NCR2, we know from Pascal's triangle, gives us 15. Okay. Notice that this number here matches the number at the very end, too, right? But would it have mattered if I made it match this one? If I did 6 NCR2 or 6 NCR4, would it have mattered? Would it have made a difference? No, because 6 NCR2 and 6 NCR4 are the exact same number. Because the number of ways you could choose a group of 2 makes out of 6 is the exact same number of ways you could choose 4 misses out of 6. Okay? The number of ways you could choose 2 out of a group of 6 is exactly equal to the number of ways you could choose 4. Because every time you choose a group of 2 to be in the group, you're choosing 4 to not be in the group. So the number of different groups is going to equal. So even if you would do 6C4 here instead, if you mix that up, you still get the right answer. Okay? Alright, so let's make this a little more complicated problem. Here, this is what I'm also going to be asking you. Okay? Let's up it all the way to 30 shots. Okay? So Paul's going to shoot 30 shots. What's the probability that he makes 25 of them? Okay? Well, first of all, do you think this probability is going to be a high number or a low number? Low. 25 out of 30, that's like almost, well, that's 83, 84%. So I'm asking you, what's the probability that a 65% free throw shooter all of a sudden jumps to an 85% shooter when he shoots 30 shots? So this is probably going to be a small number. Okay? How would we calculate the probability of him making 25?
30
NCR 25.
30 NCR 25, or you could have done 30 NCR 5. Doesn't matter, you'll get the same thing, okay? And then you'll have 0.65 raised to the 25th power, because 0.65 represents him making a shot, and how many shots do we want to know if he can make? 25 of them, but we still then need to multiply that by 0.35 to the 5th power. Okay? What is it?
1.57%.
So about 0.016 if we just kept it as a decimal. Am I hearing that right? Okay. So about 0.106, about 1.6%. Okay, a little more than 1.5%. And not highly likely. Possible, but not highly likely. Like you guys thought, though. You guys didn't think that would be very likely if you if a 65% free throw shooter is going to the free
No, but I believe in Paul.
Right.
Dude, he's Asian.
I believe I can get in Paul's head and make him miss a lot.
Miss more often than me.
He's changed after that 3 mile.
Yeah.
He's a new guy.
He's a new man.
Okay? Questions, guys, on that? Please ask. We did another one. Take the reading test you took 2 days ago on Iowa
No.
Basic Skills. Let's say you just didn't even bother to read everything and you just guessed on everyone. Okay?
That's what I did.
All right? It was a multiple choice test. It was a multiple choice test. There were 40 questions on it. Okay? Each question had A through D as its choices to choose from, right? A, B, C, or D. Okay? So obviously then what's the probability when you guess that you get the question right? 25%. What's the probability you get it wrong? 75%, right? So if somebody would go through and truly guess on all of them, never even read anything, just make a random guess, all right? The probability of getting 15 of those questions correct. Well, we would do 40 NCR 15, or you could also do 40 NCR 25, right? Get the same number. Now, why'd I do 0.25 to the 15th power? 25% of it getting it right,
And you're getting 15 right.
and we want to know how likely it would be to get 15 correct. But if we get 15 correct, then we got to be getting 25 of them wrong. The probability you get a question wrong is 0.75 raised to the 25 power. Okay, and then we did that, and we got about 2.8%. Okay, so it's highly unlikely that by guessing you would get 15 out of the 40 questions correct.
One time on that like skills tutor thing we did, I hit all C's for him, and I got 60%.
Yeah.
Miss Martin found out because she looked back and noticed that I hit all C's, but still I got 60% off that.
Yeah. The other thing I find interesting, find the probability of getting 1 correct.
Oh, it's high. It's got to be high.
No, it's low.
What would you do?
It'd be high.
40 C1
40 C1. Okay, those of you with calculators start doing this.
times 0.25 raised to the first power. And then 0.75 raised to the 39.
It's like less, it's like .000.
That doesn't make sense.
That's how much we're getting wrong.
0.0001.
Better chance of getting
1 out of 40.
That's
15 right than getting 1 right? Doesn't make sense.
See if,
Why?
That's right. Well, because it's easier to get 1 out of 40 than to get 15 out of 40.
But this is getting exactly 1 correct.
Oh.
The probability of getting only one problem, not at least one.
I
Yeah.
thought you were doing at least 1.
At least one? Oh, the probability of getting at least 1 correct is going to be almost 100.
Yeah, because I could just.
No, this is the probability of getting 1 answer right.
Oh.
Okay? That's why I have seen where a student has only gotten 1 or 2 right on a math test. And I'm sure they didn't. But the probability of that happening, you almost have to know the right answer and purposely select the wrong one for that. I mean, the probability of this happening was 0.0001. I mean, 1/100th of a percent.
So I'm gonna do that next.
The probability that you get 1 right, it's like you purposely knew all the
Come on,
answers and
Steve.
chose all the wrong ones.
That's what you gotta do on like
Okay.
vocabulary or something that doesn't matter.
Because just by complete
You only try on
randomness,
math and
you're gonna get
only reading
6,
actually
7,
gives
8,
you
9,
what
10,
you
somewhere in there.
Special
If you
reading
truly
class.
just guess on everything.
probably.
I want to go higher. So
It's possible.
Try
It is.
reading
It is
math.
very possible. Yes, it is much more possible than winning the lottery. Absolutely. Okay.
no,
So
I already won the
I'm
lottery
gonna do that
4
next time I take a
times.
math test. I'm just gonna write down one answer that I know.
Then just leave every other one blank.
Like those people
What?
had
Well, yes. They didn't leave a
And
point.
like
They just
all your
like
kids,
pick
like,
complete.
and all their kids, like-
Was it like an ITBS type
Yeah.
deal?
$1 million.
Really?
And that's almost impressive.
Yeah.
Add to it?
Yeah, I
won't even get
Were they, how old were they? Were they like junior,
I
sophomore?
don't remember.
Because if it was like a junior, that'd be like,
Yeah.
right?
So
Might have
anyway,
been Alg-
I
might have
know
been
what
Alg
we're doing,
Trojan.
so I'm gonna stop this.
20 generations.